So let's pick it up where we left off on the previous recording. Just here briefly again, the image of a microscope, standard binocular microscope. The parts that you should know are the two ocular lenses up here. Then the portion where you're carrying the microscope here, that would be the arm, is always supposed to support the base as you're carrying a microscope. The part where your slide goes on is the stage right here, and there are these stage clips as well. Below the stage, you have the substage condenser and the iris diaphragm lever that controls the amount of light that goes comes from the light source and then hits your specimen. Then your objective lenses, a set of objective lenses here are 3 that you can see, 1, 2, 3, embedded here into this revolving nose piece, and then we have the fine and coarse adjustment knob or focus knobs to move the stage up, bring your image in focus. So that's it on the microscope. Nothing further I have to say. You really don't need much of microscopy for this course. Let's continue here with an intro to the metric system, and we'll start with a review of the metric measures. The metric system got its name from the length measure, and that is the meter. You should always have some sort of mental image of how much is a meter. It's the definition here is given to you, but it's not very useful. You can read through this, but it has to do with the spectrum of krypton 86, but that's not very useful. So a meter is a little bit more than a yard. I mean, I would prefer if you sort of forget about the English system, but most likely that's not going to happen. So from your English system, what you are familiar with is a yard, and a meter is a little bit more than a yard. So that's kind of a useful measure. So it's a sizable length measure. The gram is your unit measure for mass, and a gram isn't all that much. It's maybe a small paper clip. It's a fairly small unit measure. The liter is a sizable measure for volume, and it is equal to 1 cubic decimeter of volume. So if you would put, so decimeter is 1/10 of a meter, so that's 10 centimeters, and you cube that, that's the volume for 1 liter. Again, it's maybe not super useful, but you can probably picture a small water bottle. They are typically 500 milliliters, so that's a half a liter. So 2 of those small size water bottles, or 1 bigger water bottle, that's a liter of volume. The temperature measure, or for heat, the heat measure that we're using in science is the Celsius scale. That's particularly true for biology, because in biology everything is based on life, and life on planet Earth revolves around water, and so we're using the properties of water in the Celsius scale. The Celsius scale divides up the temperature from 0 to 100, so that would be the freezing point of water to the boiling point of water. And of course, for biological systems, those are the most important temperatures that you would find. Body temperature for humans is 37 degrees Celsius, and again, we're revolving everything around the properties of water with the Celsius scale. The Kelvin scale is also useful because it starts with 0 when it's actually the absolute 0 in the universe. So when there's no molecular movement, that's when Kelvin is 0. And in chemistry and in physics, people like to use the Kelvin scale. Now, the Fahrenheit scale is pretty much not so useful, so you should forget about it. Use either Kelvin or Celsius. But anyway, in our daily use, we hear a lot about Fahrenheit, and that's what you're probably most familiar with. But in the lab or in science, we do not use Fahrenheit. We use either Celsius or we use the Kelvin scale. That said, let's take a look at how the metric system is so useful. And the reason why it is used in science is because it is so easy to move up and down by using decimal points. So you have your unit measures here, your meter, your gram, your liter, and the Celsius scale. So we're going to focus on the first 3 here, the gram, and the liter, and the meter. So now if you want to describe that something is 1,000 times bigger than a meter, so then instead of figuring out another measure, unit measure, like you would have in English system, where you go from feet to yards and to miles, and always have different measures. In the metric system, we stick with the base measure, but attach a prefix. And the summary of these prefixes are listed right here. And so in biology, we tend to go smaller. And so we need to denote what a tenth of the unit measure would be. So 1/10 of a meter gets the prefix deci and a little symbol d, so it would be a decimeter, and it's 1/10 of a meter. If something is 1/100th of the base, then it will be centi as a prefix. Symbol is a little c, and it's 10 to the minus 2, so it's 1/100th of the base measure. Very popular is the centimeter. That is 1/100th of the meter, and it's abbreviated as cm. Also very popular, maybe the most popular of these prefixes, is the milli, 1/1000th of the base measure. The symbol is a little m, and it's 10 to the minus 3, or 1/1000th of the base measure. So you have the millimeter or the milliliter. So those would be all 1/1000th of the base measure. In biology, a lot of times, especially if you do look at cells, you also need even smaller measures. 1/1,000,000th of the base measure is micro, and it's 10 to the minus 6, or 1/1,000,000th of the base measure. And since we already used up the little m as a symbol, we need to go to the Greek language and borrow the mu from there. It's that u that has sort of a sideline, so it goes down first, and it's like a U that's attached like this. On chemistry especially, or also if you go into molecular biology, then you also need even smaller measures. 1/1000th of the base measure is nano, and that's 10 to the minus 9, or 1/1000th, and the symbol for abbreviation is n, so like a nanometer, that would be 1/1000th of a meter. And then you can go even smaller, that would be pico, and there's even more, femto, atto. But anyway, we're going to stop right here. Pico is our last one right here, and the symbol is p for abbreviation, and that will be 10 to the minus 12. By far, the ones that you need to know the most are, and I'm going to highlight this here or put an X on it, so you definitely need to know centi, milli, and micro. These would be our most important ones, and for sure we will use these all the time. Moving on here to the next page, here are some examples given for the gram, so the mass unit, liter, volume, and then here the meter, the length measurement. Some examples given that are very important. Let's move on to the measures for temperature, and we will be using the Celsius scale, because for biological systems that's the most useful one. And there you have everything's based on water. 0 Celsius is freezing of water, 25 degrees Celsius is about room temperature, 37 degrees is body temperature, and 100 degrees Celsius is boiling of water, that is. And here you have the Fahrenheit equivalent temperatures. But these are the ones that you need to know. So these here, right here. And the conversion between Celsius to Fahrenheit is given to you right here, Celsius to Fahrenheit. So if you ever have to do this, but this would be something that is given to you. Also grams to pounds or meters to feet. These kind of conversions I would always give you. I don't expect you to memorize these formulas, but you do need to know how to use them. So here's your first thing that you need to do, calculations, and we will talk about the answers in a little bit later. So please make sure that you do this exercise here on these calculations on page 7. And here's another metric review problem worksheet that you should do. So here's on part B. Please do this entire worksheet. It's on page 17, and I will create another video that talks about the answers, and we'll go over this, but please try to do this yourself first. And once you're done with all of those metrics problems and the conversions and moving the decimal point, then I would like you to go to the data report page, and that's page 13. So this is where the third part of each lab starts. It's usually labeled data report pages. And here you're supposed to practice making some observations and forming hypotheses. So you make any observation that you like and then just write it down. So just think about making some observation either about your body. Let's say you make the observation that your heart rate increases when you exercise, or that you start sweating when it's hot, or whatever it is, that your hair grows, whatever you might be wondering about. So write it down and then practice forming a hypothesis, and it could be anything. It's up to you. I'll give you some examples when we go over the answers for the lab, but just start thinking about it, making observations, and then finding sort of your first guess explanation for what you observed. And then here are some more observations given to you, and you're supposed to practice forming hypotheses. So please come up with that, and we'll talk about it at the end again. And then here you're supposed to make decisions on whether you think a hypothesis is testable or not. And remember, we are in science, and everything has to be measurable. So as long as it's measurable, then it is testable and it's a good hypothesis. If it's not testable by experiment, then it's not a scientifically valid hypothesis. So you should practice that and come up with some ideas of how you would test those kind of statements that are given there, these observations. And then here, experimental design step by step. So choose one of the hypotheses and think of an experimental design, how you would test the hypothesis. And then we will be talking about some of these other considerations regarding the hypothesis and hypothesis testing. So we'll take a look at that and sort of find a transition to the statistical analysis that will be part of lab number 2. And so we'll go over this at the end, but this is your assignment for the lab, to do the metrics problems and make observations and practice forming hypotheses and all of that. So one last thing before I let you do the work and figure the metrics problems out. You might want to take a look at the appendix handout that I posted in this lab for you. So take a look at Appendix A. It's common metrics units. You find a review of the basic units again, and the prefixes listed right here too, and the common conversion factors are listed here for you in part 3, including the conversion Celsius to Fahrenheit and Fahrenheit to Celsius. That might be a useful reference here. And then also the unit prefixes here one more time, also going bigger, like kilo, mega. These prefixes are listed here. It's a more complete list. And then maybe this is helpful, how many decimal places you would have to move decimal point, how many places to the left or to the right. So if you're going from meter to kilo, so from the base unit to kilo, that means you have a factor of times 1,000. You're going 1,000 times bigger. That means you need to move your decimal 3 places to the left. So let me give you an example. If I want to express 1,000 meters in kilometers, then I need to move my decimal 3 places to the left. That means I'm going from here 1, 2, 3, and then that means I have 1.000, but I don't have to express this 1 kilometer. So I think you can get the idea. This might be useful for you to as a reference as you're doing your conversions.